Hello, and thank you for joining today's webinar, IoT Connectivity, Leading Digital Transformation Across Industries. My name is Linda Manasa, and I will be your moderator for today. Before we get started, I wanted to go over a few housekeeping items. This webcast will be recorded and available on demand 24 hours after the webcast has ended and can be accessed using the same audience link that was sent to you earlier. If you're having technical difficulties or the slides are not advancing, simply refresh your browser. Any content-related questions will be answered during the end of the presentation, where we allotted time for. You can submit your questions at any time in the Q&A box. Any questions not answered not during the webcast will be answered via email. Without further ado, joining us today is Z. Z is the CTO at Aeris and is responsible for the architecture and future direction of Aeris network and technology strategy. Z has more than 38 years of experience in the semiconductor, computer, and telecommunication industry, including product development, architecture design, and technical management. He holds a Bachelor of Science degree in Computer Science and Engineering from MIT. Thanks for joining us, Z. Please go ahead.
Thank you very much, Linda. Before I get started in the meat of the presentation about the topic today, I'll give you a little bit of information, a few slides on Aeris, who we are, what we do, for those of you who may not know us. And essentially, we are a global technology partner for helping our customers go from unconnected IoT devices to connected IoT services. Okay, if they have products that need to provide IoT services, we help them. It is a global company. We have offices in the United States, we have offices in Europe, India, and various places around the world. And we provide services in a large number of countries. Well over 180 countries, we have ability to provide IoT services. So if you look at who we are from the perspective of the numbers, we have arrangements with a lot of carriers in a global environment where we manage the cellular IoT application services that our customers can use. We have well over 15 million devices today, which puts us in the top 10 in terms of the global IoT cellular units service providers in the world today. And we're processing over almost 1.5 billion IoT messages per day at the current time. These are all for our customers. We do not deploy IoT applications ourselves. We help customers reach these markets in these various areas, various countries, for the devices and applications that they have. Broad industry range, if you look at the kinds of applications that are deployed in IoT, and this is the important point that I think the rest of the presentation will also help you understand, is that IoT can apply to a large number of markets. Not surprisingly, automotive is near the top because it is a mobile application, so the services we provide in the cellular IoT space using cellular technologies would be very applicable to automotive. And it goes down from there: healthcare, trucking, utilities, etc. Obviously, anything that needs to be physically in motion, such as a trucking industry, a truck, or an automotive application inside a car, connected car solutions, it makes a lot of sense to use cellular, and that's the majority of the businesses that operate using our services today. Now, before we get started into the meat of the presentation, I'd like to get input from the audience on where they are on their digital transformation journey. So Linda, if you could bring up the poll, and I will read through the question and the possible answers that the audience members can select from.
Thank you. The poll is now live, and I'll give the audience 1 minute to answer the question.
Okay, so there are 4 selections that I would like people to pick from. In essence, I'm trying to get a feel for what level of experience people have with digital transformation. So it ranges from just getting started all the way up to having done multiple solutions, potentially with IoT applications in place as well. So if you could pick one of the 4 potential answers and give us some feedback as to what stage of the company for you and your products and your services are at, that would be good. So the 4 answers, once again, just learning about what it takes to begin digital transformation for our company. In the early stages of beginning our first digital transformation project, if you've launched a digital project already that includes an IoT application, or you have lots of experience deploying IoT applications at large scale, and therefore digital transformation is something effectively you have done already. Linda will give them a minute or so. I'll let you control when the voting stops, and I can go back to the list.
Great. I'll just give the audience a couple more seconds.
Thank you.
All right, Dee, I think I'm going to stop the voting and you can just read back the results.
Okay, it's interesting. Almost everybody picked what it takes to begin digital transformation of our company. Okay, that's interesting. I'm actually a little surprised by that based on a slide that I will show you later on. But it's good because it means that my early slides that I'm going to talk about digital transformation may be more meaningful, and I'll spend a little bit more time on that than I might have for people who had a lot of experience with digital transformation. So it might make sense for me to go forward over here with the agenda for today. I'm going to talk about digital transformation. I'll spend more time on that than I might have with the definitions, the objectives of what people need from digital transformation, some truths and myths. People misunderstand what it's all about. I will spend some time about discussing about why you might want to transform your business. What are the expectations you have from the business? What information do you successfully need to be able to transform your business, whether you're getting the data from various sources and sensors, and then, of course, how to transport that data. Now, I'm going to be focused on cellular connectivity for the obvious reason that that's what the topic of this presentation is all about, but the objective is to achieve the digital transformation that people want from their businesses to be successful. And then finally, I'll close with some what to watch out for. If you're trying to meet certain objectives, particularly when you're using cellular connectivity, what should you watch out for? What are the issues that you can encounter that might not give you the data and the information you need to be successful? So let's get started. First off, what is digital transformation? It means many things to many people. I'm going to give you a couple of definitions and a couple of ways that people are using digital transformation, and then we'll get into the meat of the presentation. First, it could be a migration. Maybe you have some internal systems where you've been doing things partially on a computer, a server within your own hosted networks, or perhaps maybe even doing some manual processing, and now you need to transform it into the cloud, maybe provide a solution that gives you access to the tools and capabilities that the traditional cloud players provide. Service providers make available for you so that you can migrate your systems to the cloud and basically get the computing capabilities and processing capabilities and data storage capabilities of those systems. Maybe it means to modernize. Maybe your processes are a little bit on the old school way of thinking. Maybe there's a lot of human interaction, and maybe that causes you not to be able to respond to the requests from your customers sufficiently quickly, and therefore you may want to have a change where you are now processing information digitally, maybe in the cloud, and that gives you the kind of capabilities and support capabilities that your customers need. I think the final bullet on application services may be something that if you find that you can't build it in-house because you don't have the resources, the people necessary to provide an application, and you want to get support from some external company, in this day and age, using a cloud-based solution that is digital, essentially part of the digital transformation process, if you will, that will allow you to deploy those new applications in the cloud from an external third-party provider of services. I think that the quotation that I have from George Westerman says it all. It's a radical rethinking of how an organization uses technology, people, and processes to fundamentally change their performance, do something way better. It could be disruptive, which is where the word radical comes in here from, or it could be incremental because you've got a solution already and you want to make improvements to it because you want to stay ahead of the curve. What are the objectives that you might want out of a digital transformation experience? Number one is to be able to deliver a superior customer experience. If you've got an existing customer and you want to retain them or you want to attract new customers, that's what digital transformation tools and a process can give you. It allows you to respond to change very, very quickly. If you have a new opportunity, you need to be able to take advantage of that. I think the picture on the upper right is actually very, very illustrative because it shows you an example of a telemedicine doctor-client-patient interaction. That is something that was surprisingly not in play in the early part of this year, as a matter of fact, in the United States. There's a study that shows that more than 80% of the doctors had absolutely no telehealth capability available in the United States for their patients, simply because they weren't expecting to be in that position. Yet things changed, and as we all know, because of the shutdown of the country, it was impossible to get patients to go in and see doctors, so telehealth has become sort of the norm. And there are other countries where it is more commonly practiced. For example, in India, where you have rural communities that simply cannot go in to see a doctor, where telehealth is a bigger deal. Here in the US, it was not as much of a big deal, and it has proven to be important. So that is an example of a transformation from a manual process of patient-doctor interaction to a telehealth solution, which required technology that the doctors had to make available to themselves, let alone to their patients. And of course, finally, the benefit of digital transformation is that you need to make sure that everybody in the company is benefited. Whether it's the developers who put in the code together for the digital transformation, whether it's a new team that is called the DevOps team that is delivering these systems to the operations team within the company that actually serves the business and the customers, provides the feedback to the management team, and of course provides all of this to the customers who are going to be ultimately the beneficiary of the digital transformation that the company goes through. Some truths about digital transformation, some things you need to be aware of. And I'm just going to give you a few bullet points. There are obviously more things to keep in mind. It isn't a shrink-wrapped solution. It's not something you can just go buy off the shelf, even though there's going to be a lot of spending. IDC has noted that by 2022, the digital transformation technology spending is going to be upwards or nearly $2 trillion around the world, which is pretty significant. It's not something that you can deploy instantly. It's not an application service. Okay. Another truth: it's not just a goal that has to be achieved, a desired outcome. It's a journey, meaning that you take intermediate steps because the process may be so large that not taking the intermediate steps would make you lose sight of your objective, or perhaps you would get some kind of feedback that said that you're not achieving it fast enough, etc. So you need to be careful about the implementation of any digital transformation project. And finally, you have to have data. You have to analyze that data, that information that you need for that digital transformation to measure your success. Is it working? Is the transformation you're doing good for your customer base that needs to have that transform occur? Is it doing what you need to achieve the efficiencies within your company? You got to get data. You got to do the analysis, and that's primarily what I'm going to focus on for a major portion of the presentation today. Also, in addition to the truth, I'm going to talk about a few myths. Okay, people get very confused. They always think that only the IT department needs to implement a digital transform. We're going to put more laptops in the company, or we're going to buy some software that everyone uses. No, it's not that. It's a process change, and so you need to make sure that people who are going to be affected by that process are involved, because you need to succeed in the digital transformation process change. And if somebody needs to be part of that process, they need to be actively involved right from the beginning. Another thing that's very important is to understand that C-level support is not a guarantee. People assume that just because you've come up with this digital transformation, that the upper management has said, yeah, go for it, and forgetting about the cost aspect of it, or what it takes to implement it at all levels in the organization, because you need to justify it. What is the investment you need to do? What is the return you're expecting? And why should you do it, on all those details? And finally, another myth that's kind of an interesting thing that I think people forget about is they just think it's a project that can have an end date. You can start it, you can finish it, and you're done. You have no intermediate goals, and you don't need to keep improving it after you're done with that project. The answer is no. There's a quote, I think, from Gene Ross. He's a scientist at MIT Sloan School, who pointed out that even though digital is supposed to be all about speed, it takes a long time. Digital transformation doesn't happen overnight. It takes effort. You have to set intermediate goals, and you have to come back and evolve it, change it over time. Make sure that what the goals that you're achieving are the goals that you wanted, the objectives that you wanted, and therefore what you need to do to improve them over time, because you're going to need to keep up. Finally, keep in mind that there are plenty of digital transformation projects well underway. There was a study done by F5, a company in the security business, networking security business, who looked at what was being done for digital transformation, and they came up with this. And this is where I expressed a bit of a surprise from the audience response to the first poll, because in their study, it may have been the specifics of the field they're in, which is security. They believe that about 80% of the organizations are already executing on digital transformation projects. 87% of them use multi-cloud redundancy. What does that mean? What that says is that they go to one service provider for cloud solutions, and they don't just rely on them, they rely on the availability of multiple service providers, multiple cloud providers to be able to have redundancy in their solution, etc. I'm not going to read through every one of them. I just want you to understand that there are people who are already doing digital transformations. You need to be careful about your competition who may go past you if you're not making sure that your processes, your solutions are keeping up with the customer's requirements, because if somebody puts in place a disruptive mechanism, you could get hurt for your solutions and your sales and your revenue. Now, why do you want to do digital transformation? I want to emphasize, let's keep it simple. Okay. Now, this is a chart that I think is a little bit simplistic, and I'll be the first to admit that. There are nuances that I don't discuss in this presentation like I've done in the past. Really, the bottom line is that if you have an enterprise, you have a business, there are two ways to get to better profit. You either increase your revenue or you reduce your costs. And both of those are areas where digital transformation can help. You can improve the efficiency within your company. That makes your costs go down. Maybe you can improve the solutions that you provide to your customer. You improve your support. That can cause your revenue to rise, and the delta between them is obviously the profit. It's the reason why companies exist. Now, there are nuances here, meaning that regulations might force you to do certain things. For example, legal requirements to implement certain functionality that only a digital transformation will get you there, et cetera, et cetera. But those are nuances that I don't talk about in this presentation, and I have done so in other areas. Let's also then focus on the data aspect of it. You want to make sure that you understand that data drives your decisions, okay? And you have to be data-driven. You have to gather your inputs, whether it's financial inputs, sales inputs, IoT data, or whether you're gathering any kind of information that is relevant to the decision that you're trying to make. You need to make sure you collect it all together and look for those patterns. Find the patterns which is going to give you the insight necessary to be able to make that decision and transform your business. You have to use techniques such as machine learning and artificial intelligence to implement the kinds of insights that you get back from the data that you analyze, and then you feed it back into the business and you take the actions to improve and evolve. Now, this is not a one-time process. You have to iterate. If you're going to be an incremental digital transformation, or whether you're implementing a disruptive digital transformation, you're going to find that some of the insights that you gather may lead you to say, oh, okay, my data wasn't sufficient, or my data needs improvement, or now that I've made the change, what new data do I need to gather to see if my solutions, my actions that I took, my business decisions that I made were appropriate, and if not, can I go back and change them and improve the results even more? So gather the data, process the data for the patterns, find the data insights that you need, put it back into the business to solve the problems you were trying to solve, and then repeat the loop. How often, or how well, or how much data it's just totally dependent on the problem that you're looking at, the decision you may need to make, but the process is the same. Let's talk a little bit about how you analyze data and you make sure that it is useful for you. Far left, you have the data gathering. You have sources. You get the relevant data that you need for the information that you need to extract from it to make the decision that you need to make. This may involve multiple sources. It may involve IoT data. It may involve connected data that you believe has an impact or an influence on the outcome that you're looking for. You store the data. Maybe you normalize it to make sure it's comparable. IoT data may be different from gathering data from a customer satisfaction survey. So you need to compare and normalize that in some way that makes it possible for you to be able to make a decision based on the analysis. Then you organize the data. We're using perhaps a simplified version where you have the appropriate reports and summaries you can pull from, and then you do the mining. You find the insights and present it to the human beings who may need to make that the decisions associated with the data that's coming in. I don't use AI in this particular model. I'm sticking to human. The assumption is human business actions in this particular case, although in time, if the data volume is large enough, you may need to have AI techniques to make those decisions for you. Now, where is the data going to come from? It could be what I call sensors. Now, financial data is a sensor. It is an input to your process. Could be purchase orders, could be your backlog, could be your revenue, could be your sales, maybe getting the daily sales reports for the period that you're trying to make decisions on. Could be satisfaction surveys from customers, maybe market research. Analysts provide you information. You get research reports that drive your decisions. And obviously, when you're trying to do a function that is related to IoT, it could be measurements from remote units. Now, my presentation is going to focus on the measurements from the remote units only. I'm not going to talk about the other aspects of the data that you feed for a digital transformation. Those things are inputs to your processes and the digital transformations you're trying to make. I'm going to focus exclusively on the IoT applications and devices. So before I get started into that, let me do another poll. Linda, I'm going to hand it back to you to sort of get an answer from the people on where they're expecting to deploy IoT devices. There are 4 answers that are possible over here.
I think so the polling is live, so I'll give the audience a minute to answer the poll question.
Very good. The 4 answers that are possible will be USA only, North America only, or North America looking to scale into Europe, possibly beyond Europe, but looking to scale into Europe, or perhaps doing a global deployment. And the reason we're asking this question is because we can support customers in different ways around the world. The capabilities and technologies that are available, perhaps in the United States, would not necessarily, for example, for what I'm going to talk about, for the 4G LTE technologies, may not be available everywhere in other countries. So I'm going to use this as a driver for us to help make drive the rest of this discussion and topic, as well as potentially where I can see customers asking questions about. So.
Great. We'll give the audience just a couple more seconds to answer the poll question. All right, I'm going to stop the voting. MC, would you like to address the responses?
Yeah, it looks like about 2/3 of the people responded that they will only be deploying IoT devices in the USA. That's interesting, and I think that means that my presentation is actually going to be relatively in tune with their needs, including North America. I will focus less on some of what's outside the North American and European markets. So the folks who are responding about doing a global deployment, hopefully I will touch base on sufficient information and provide sufficient detail that they can understand what they're up to, and maybe we can answer questions from them later on, or have contacts. They could contact us and we can give them additional information about global services for a global IoT solution. All right, so let's go forward and talk about the kinds of technology that has an impact in IoT. Obviously, there are more than these 4 bullets. Data connectivity is an obvious one. That's what I'm going to talk about in the majority of this presentation, is what kind of long-range data communication makes sense from an IoT device. The issues of security, privacy, whether you use encryption, who has access to the data, what kind of analytics you might want to have for that data, etc. The alerting functions, doing rapid application deployment are topics that we have covered in other webinars, or we can cover in other webinars later on. I'm going to focus primarily on data connectivity, and specifically cellular IoT data connectivity, because that's what we do. So let's dive right in. What are the IoT connectivity requirements that people think is necessary for their applications to be successful? Obviously, you need coverage. You need to make sure that you have long-range coverage, whether it's national or even global kind of coverage. You need to make sure that you have the ability to send and receive data anywhere. You need to have reliable communication services, because if you don't have service, then your quality of the information that you gather for your transformation or whatever function it is you're trying to provide, as well as the ability to make sure your devices are still very secure, goes down. You need to monitor those remote devices. You need to make sure that somebody is looking out for them to make sure that the data that you're gathering from them is relevant and that the devices have not gone down. You need the uptime. You need to maximize the application uptime. Obviously, you need to support IoT applications that scale in the future. As the various analysts have been telling you, we have more than a few billion devices available already, and the question is, how can you get to the large-scale deployments of multiple billions of devices that need to be deployed? So you need to have low power for those kinds of massive unit deployments, because the use of energy, use of battery-powered devices is going up steadily, and the energy usage is going down steadily. because you do not want to have to worry about requiring power from the utility grid, etc. Those kinds of applications are going to have an impact. And so those are part of the requirements that you need to have for these solutions that you deploy. Now, data transports in general, I'm sort of making a few general comments over here. They could be short range. It could be a Bluetooth application from a measurement of a Fitbit-like sensor that to your handset. It could be a medical device. I happen to use a diabetic sugar test device that sends data to my handset. Or it could be long range, okay? It could be like a cellular data service from that provides connectivity to a vehicle or to a tractor or to a sensor or an oil derrick out somewhere. The point is that you could have a variety of different transports that are available to you. It could be wired, could be wireless, could be very high speed if you're sending medical images, or it could be a low data rate because you're looking for a door sensor to provide you data or a temperature sensor out in the field somewhere. It could be real time and you need to take actions fairly quickly, or it could be latency tolerant. If I'm reporting the level of a propane tank that is being used for heating services, all I really need to know is that maybe on a daily basis that the sensor is okay and maybe that the amount of propane that's available is sufficient for the particular application. I don't need to have real-time data being sent to me necessarily. And obviously you need to have various kinds of choices that are available to you, and you need to make a selection based on your application. I'm going to focus on cellular IoT because it is one of the choices. Today, if you look at 2G, 3G, and to a degree 4G LTE, you have global coverage available everywhere. We provide that global service. There are other companies that provide their global services, and the characteristics of the global service need to match what the application requirements are, obviously. I'm going to talk and focus more on the low-power wide area networks, LPWAN or LPWAN. I want people to remember that acronym because I'm going to focus on the cellular versions of that LPWAN, the LTE-M and NB-IoT. I'll give you more information about that in a moment. I'm not going to focus on the proprietary LPWAN solutions. I'm really going to stick to the standards. And I'm going to talk about 5G massive machine communications. And I want to make it very, very clear that people understand this. 5G is a future technology that gives you very high performance, but something that people tend to not understand or realize is that the massive machine communication portions of the 5G standards are really starting out with the LTE-M and NB-IoT technology capabilities, which are built into those standards. And yes, there may be future versions of other massive machine communications technologies that are ultimately included in 5G, but for starters, LTE-M and NB-IoT are part of the 5G standards. So when I use, one of the questions I tend to get asked is, well, when 5G is fully deployed, will LTE-M and NB-IoT cease to exist? And the answer is no. It's part of the standard. It's one of the capabilities that are included in there. And so it will be available through the, the duration of the 5G standards as well. It is the next-gen technology that is based on 4G LTE, reduced throughput versions of 4G LTE, essentially. The GSMA has taken these two technologies and coined a new phrase for it. They call it the mobile IoT. They wanted to distinguish between some of the other proposals that had been made for low-power wide area network technologies in the cellular standards, and they coined this phrase mobile IoT to represent these two standards. LTE-M stands for LTE category M. I think the letter M came from machines. The idea is that people implementing IoT applications would want to use LTE-M. Essentially, it's a narrow bandwidth with slower data rates than 4G LTE. And then they came up with another one called NB-IoT because they had some characteristic requirements for battery usage for long application and device deployments, which basically uses even a narrower data rate, a narrower band than LTE, and so therefore it has slower data rates than LTE, but for the kinds of applications that NB-IoT is targeted for, that would be perfectly fine. Obviously, 5G cellular is coming along. The full standards are becoming available. They're going to get ratified within the next year or so at the maximum, and you can start seeing 5G cellular deployments already. And again, I want to emphasize that standard includes LTE-M and NB-IoT. Interesting comment from the global head of IoT at the GSMA that NB-IoT will become an essential tool to adapting to COVID-19. Now, the reason he said that is because I think he was thinking ahead of what kind of devices might be available to do data measurements on a large global scale. And I agree with him, and actually I have a presentation that I'm in the process of putting together where I talk about how those two low-power technologies will be appropriate for post-COVID-19 support for IoT devices that can help eliminate or minimize or mitigate some of the issues associated with COVID-19 as well as future virus outbreaks. Now, people assume in cellular that if you have enough bars, your application will work perfectly. And that's not a good assumption. The problem is that it isn't just the signal strength from the tower. What you need to worry about is what happens beyond that, okay? Where does that information from the tower go to? What's the complexity? And people don't appreciate sometimes what difficulty the cellular industry has to spend time on, the standards, the equipment, the deployment, the networks, to support that capability for having a wireless device do information from a smartphone, let alone the wireless data that you might have from a dumber IoT device where you don't have a human being providing the intelligence to make decisions about service quality at a given location, et cetera, et cetera. There is complexity. Now, I don't want people to get scared by this diagram. I just sort of at a higher level, I'm taking out the functionality from the traditional networks that are available today, whether it's 2G, 3G, 4G, or even LTE-M, and start to talk about what does the end-to-end IoT network look like. On the far left, in the dashed box, is the device that's out in the field, communicating with the towers that are associated with cellular service. On the far right, the upper right, you see the data application servers, perhaps in the cloud. In between are all of the standardized complexities that the network has to deal with. These are elements that process the data, that manage the connection to the device and make sure that it is reachable, store the information about the accounts, et cetera, et cetera. Customers, people who are deploying IoT applications, whether they're putting the applications out in the field on the far left or doing their own analysis of the data for their digital transformation projects on the far right, don't have to worry about the middle. And that's why I'm trying to make sure that people think of it in simpler terms. You have your things, shown on the left, the connected things. On the right is your provider's cloud, whether it's your own application running in the cloud or somebody who's providing that capability for you. You can treat the middle as somewhat of a black box. The radio access networks that I show there are still important, even though they're part of the cellular service. And the reason I bring it up is because the connection from the thing to the radio access network is important. You need to understand under what conditions the service availability, the tower signal strength, or what the congestion might be occurring, et cetera, impacts your device behavior and what you need to do to avoid some of those issues. But the core can be treated as a black box. Assume that a provider who's doing IoT services, for example, my company, which is doing the IoT services for the cellular IoT solutions, will manage that for you. They will deal with the core. They will deal with what it takes to get the data from the device through the radio network into the core, and then provide that data into the solution provider's cloud, whether it's your own solution or it's a solution that we provide on behalf of our customer, or maybe it is something that a company that's doing cloud solutions is providing for you. Think of it in simpler terms. We'll abstract away and deal with the mobile core. You need to worry about the interaction to the tower, and you need to worry about the analytics and transformation data that you're getting for your digital transformation projects on the far right. Now, what expectations should you have from low-power wide area networks? I'm focusing on that because I believe it is the wave of the future for the vast majority of IoT solutions that need to be deployed. Okay? First thing is that many IoT apps don't need a lot of data. Okay? You just need small data rates, low amounts of bytes in for the packets, every packet that you're sending. Maybe you need some latency tolerance. You're going to be sending somewhere south of a few hundred kilobytes, maybe a megabyte, 10 megabytes per month. Not surprisingly, even though we have millions of units on our network, the average amount of data from the devices that are out there is pretty small. Surprisingly small connected to a smartphone user. Yes, we have devices that are sending hundreds of gigabytes, but there are very few devices. More often than not, they're not sending a lot of data, so the average is quite low. You need to be able to operate on batteries, and that's where the LPWAN technologies come into play. Energy is going to be an issue. So if you have a battery-powered unit, yeah, I exclude the fact that you might have a source of power from a connected car, but if you have a battery-powered unit, you need to be able to have it operate without having to run out there and change the batteries very often. Think of a utility water meter that needs to operate for years. Maybe from a year or 2 or 5 years, or maybe even more than 10 years if you're doing a propane tank measuring device, or you're doing a door sensor for an alarm unit that doesn't have access to power. You need to put the battery in there and let it run for years, sending only a few transmissions per day. And you need to have low cost. If you're going to get to scale. You need to be able to provide radios and services that have a relatively low cost compared to the data information that they're providing, and you need to make sure your coverage is very similar to 4G. These are expectations that the LPWAN community, particularly the cellular IoT LPWAN community, is attempting to meet and has met very successfully for the kinds of applications that are being deployed today. I talked about LTE-M and NB-IoT. Let me give you a little bit of a difference between them, which I think will drive some of the choices that people might make, and I'll show you some reasons why you might want to pick one over the other in a few minutes. The questions will be dependent on the application, obviously, but we'll talk about that. Range is pretty similar. You need to be able to get from your device to a local tower that is providing the service. LTE-M is typically deployed within the LTE bands that exist already, and NB-IoT is a little bit more flexible than that. I'm not going to go into the bits and bytes and details of how you might deploy in a particular band. Let that be part of the interaction between the radio module and the tower. As long as you select the right radio module for the region you're in, you should be able to get LTE-M service and NB-IoT. Now, today you can find radios that do both. In time, you will see even lower cost NB-IoT radios that don't do LTE-M for certain class of applications. Obviously, the data rates matter. Obviously, the latency matters. And of course, depending on the battery life, the LTE-M can give you between 1 to 5 years if you manage the usage properly. NB-IoT, in theory, should be able to give you more than 10 years. Now, one important distinction I make over here is voice. I'll give you a little bit more of a descriptive, why you might pick one over the other in a few minutes. But basically, LTE-M has the ability to give you low-quality VoLTE-based voice over LTE-based voice capability. NB-IoT does not. That's one basic difference that might make a selection choice relatively easy, because if you have a voice requirement for basic voice interaction as part of the IoT device functionality, you may want to have to pick LTE-M rather than NB-IoT. Let's talk about those reasons why you'd want to pick one over the other. If you don't need real-time data, and I'm generalizing the point over here a little bit, if you do not need real-time data, NB-IoT ought to work because it has latency. It allows you to put the device to sleep much more effectively than LTE-M. As I mentioned a few minutes ago, if you need voice, if you have to have voice for your IoT application in support of the data you're transmitting, NB-IoT doesn't support that. LTE-M is the only choice you can make. If you need longer battery life, you need to consider NB-IoT. And I'm not going to go through all of these. I'm just going to point these out. And in general, you need to ask yourself some questions with regard to your application, and that will drive the choice of one over the other. Obviously, there may be some overlap, but some of those questions are pretty clear yes-no type of questions. Voice is one of them. Physical mobility is another. Today, LTE-M has mobility management, NB-IoT does not. Future revisions to the standard may allow that, but today, LTE-M, if you need normal operation of your device, respond to the fact that the device might move from one switch location to another, to potentially regional motion where it goes from one carrier to another. LTE-M has that built in, NB-IoT does not. Let's talk about 5G. What were the original technical objectives for 5G? And the reason I bring this slide up is because I think people tend to get confused about the technical objectives, in particular when you can achieve all of these objectives simultaneously. On the left, you see the objective that says we need to have 1,000 times more data being sent for 5G. Next, we need to provide billions of connected devices, way more than what is achievable today in a given network, maybe 50 billion devices in a set of networks that provide that 5G technology service. High data rates. 10 gigabits per second, much higher speeds than what we're used to today from a given 5G implementation. Maybe a few milliseconds of end-to-end latency. The data gets through way faster than what is traditionally done in 2G, 3G, or even 4G today. And I need no long battery life for those devices that are out there. I want 10 times longer battery life, maybe measured in years, rather than a few days that you might expect from a typical cell phone today. Now, I want to very carefully delineate that you cannot achieve all of these objectives simultaneously. And I think this diagram from Intel says it all. I love this diagram because if you look at what's possible, you look at some characteristics. If you want reliability, then you're going to get it. If you want high data rates, you can find it in 5G. That's where mobile broadband, the light teal colored arc shows you. But if you want massive machine communications and you want to run for years, then you cannot do that simultaneously with high data rates. Energy requirements can drive decisions about what you implement. Yes, smartphones will be very fast in 5G, but you're not going to use a smartphone for millions or billions of devices that are transmitting IoT data using batteries that last 10 years. You have to pick and choose. The vision of 5G says you can do all of these in a uniform, well-defined, standardized way. And that's really the point about 5G. The hype goes into the high-speed smartphones. The fact that you can do massive machine communications using NB-IoT and LTE-M, which are part of that 5G vision, is something that people don't talk about as much except in conferences like these and in webinars like these. What are the kinds of applications that 5G will enable? Now, bottom axis over there is the data rate. The left axis is the latency. If you look at the applications within the white box, you range from the bottom left to about real-time gaming or multi-person video calls in the upper right of the inner white box. These are technologies that typically legacy services like 2G, 3G, or even or well-suited for 4G as well in many cases. But there are new applications coming along which simply need the ultra-high performance or very low latency, such as augmented reality, virtual reality kind of solutions, and ultimately supporting autonomous driving as well, where you can see the data rate requirements and the low latency will make that more viable than anything that 3G or 4G could do today. So I like this chart because it kind of shows you where the applications fit. 4G LTE could solve many of those application requirements today, could match them very well today, but 5G in time will do a better job. Timelines for 5G, I'm not going to dive into the bits and bytes of this chart over here, but the fact is that in 2020, you're starting to see a number of 5G applications being deployed within the next 2 to 4 years. You'll see more of those. And by 2025, the estimate is that more than half of the smartphones that are out there will have 5G data services available to it and deployable in various networks around the world. Obviously, some networks will be ahead of the curve today in the US. In North America, you can start seeing 5G available in major cities already, and in many cases, particularly the sub-1 gigahertz 5G, you can start seeing it being deployed in some of the secondary and tertiary markets as well. It may take time to get 5G along all the highways, but it should happen. IoT, starting to use 5G, probably in another 2 to 4 years before you'll see any reasonable deployment for IoT devices, except, and I will emphasize this one more time, LTE-M and NB-IoT is part of that, and that's happening today, has been happening for a year or two, and will continue to happen over the next few years. I'd like to compare what I've talked about today in a little bit of a eye chart, my apologies for that, 4G standards and 5G compared to sort of the other wireless connectivity that's available, including short range, such as the technologies called NFC, near field communications, Wi-Fi, how do they all fit together, what kind of ranges. I picked a characteristic which I think sort of defines that technology. If you look at Wi-Fi, for example, I think the fact that one of the characteristics is gives you high speed over less than 100 meters is one of the interesting IoT characteristics that are useful for certain applications, perhaps in building sensors. If you look at satellites, you can get worldwide global coverage for a device that's way, way out there that you can't access because there is no cellular coverage. Perhaps it's sea, but you need to think about the fact that latency may not be appropriate for a real-time application. So there's a way of looking at all these wireless technologies and saying what's available, what's possible, what do I want to do, what kind of typical application do I want. Now the problem is when you have all these choices is how do you make a decision? How do you decide which one makes sense for your application? And the answer is you've got to have to analyze. I was doing some studies to show what a process needs to be. How do you choose what needs to be selected? Okay, most cases, many of these technologies will meet the technical objectives. So you got to look at other things. Coverage. Is my availability of service going to impact my device if it can't find any service? Do I need to deploy millions of devices and therefore maybe the radio costs would be impactful and therefore a satellite radio using a geosync satellite wouldn't be appropriate, etc. All kinds of decisions that you have to go through and understand how to deploy your application. Make it a point of talking to the experts. I want to make it very clear that we are way, way, way beyond the point where IoT is a nice to have. You can have use cases that clearly IoT is the right technology to implement, right solution, right device to deploy, because there's a well-established ecosystem that can support the global deployments that you need. I want to emphasize that IoT is here. There are millions of devices, hundreds of millions of devices already deployed in a large number of markets and industries. Your competition is active. They're doing IoT deployments. And if you look at this diagram from McKinsey, they predict by 2025 the impact of IoT on the global scale on all of these industries, whether it's the home automation, whether it's logistics, whether it's retail environments, whether it's factories implementing IoT. The impact is enormous, trillions of dollars by 2025. There is a range because obviously things could change a little bit depending on the number of devices that are deployed, but it is enormous. And so make it a point of making a decision. If you need an IoT application, go for it, get it done. I chose to use smart cities as an example over here because I was helping somebody make a decision about the kinds of technologies they might want to deploy. On the left column, you see the various applications they were looking at for that city. And on the horizontal axis are all the various technologies that are available. Today, I talked about standards-based LPWAN, cellular IoT, 4G, and 5G, but there are other technologies that are available. And depending on the application that a particular entity wants to deploy, for example, if you're deploying a consumer car, clearly you're not going to do a Bluetooth application for IoT unless you're using a handset-based approach to get that data remotely. You're probably going to pick a cellular application device unit that's deployed inside the vehicle. And obviously, satellite is a viable option in certain cases where you absolutely have to have redundant transmission of data from an emergency vehicle, perhaps. So it really is, it totally depends on your application. I'm not going to go through a chart like this for every application that's possible on the IoT in all those industries. You need to analyze that or get some help from an expert to give you some more information. In the case of a city, they may need to deploy more than one because they may have a variety of different applications. Enterprises typically will have a few applications, so the choice will be much easier for them. So what should you watch out for? Okay, you can have server congestion, you can have connectivity congestion. The amount of data that you bring in, if you have your own data center, you can have a problem with supporting that from the server base that you have. You may want to distribute that data into cloud. Something else that has a very common problem is that GPS provides you very, very accurate time. And we've seen customers who have taken data and sent it precisely on the clock, and that can create congestion in the network, it can create congestion in the backend systems that are receiving that data. So if you have an application which sends both critical and non-critical transmissions, take that non-critical data and don't send it on a reliable, regular timed interval because that's going to cause you problems. You need to find a provider who has coverage everywhere. And more importantly, when you get that provider, you need to understand that there's data being sent that is metered. You're being charged by the kilobyte, by the megabyte. So only send what you need to send, because searching that data becomes difficult. Okay? You need to be able to do edge processing, send only what you need, be able to change it with over-the-air functionality to configure it. And finally, avoid data museums. People tend to send data and then never do anything with it. Well, you've paid for that data to be transmitted, you're paying for that data to be stored, and at some point that data is going to lose value. Maybe the decision you make is no longer relevant because that data is X months old. Yes, you can learn from that data, but you lose value in that data ultimately at some point. And so you will need to make sure that you only send data that you need. Just don't assume that because the transport and connectivity is available that you're just going to send the data. So, for example, coverage issues. We've done this where we make sure that the coverage that's available to the application, usually for a connected car application in this particular case, if you have an agreement with multiple carriers, you can make sure that you provide a better solution based on a priority list. So we provide this solution where a car that is sending and receiving data has access to more than one tower, more than one carrier, and make sure that if you have a tower that's in a better position to receive that data, that it is the coverage is better, then we should do it. We did a study, we did a test for one of our car customers and was able to show them that we were able to achieve a substantial improvement in performance because we had the multiple radio access network capability. And in fact, we have some devices running around in Africa where you have multiple carriers which have very, very different coverage patterns. And so for being able to select one over the other is an important requirement. So let me summarize very quickly. Digital transformation projects are well underway. You need the data to be able to make those changes happen. One of the sources of data is IoT applications, and cellular IoT is indeed a very key way to get remote global data available to you. And of course, you're going to be able to do large-scale IoT deployments successfully. You can do it and achieve the desired digital transformation outcomes, avoid the mistakes when you work with experts and service providers who know how to do this, who have the experience how to do this. We've been doing this for well over 2 decades now for our customers, and we're pretty happy that our customers understand how we can support them, not only with connectivity, how to make sure the devices work, but also providing them the analytics engines and the analytics and storage of the data that they send for their business purposes. So that's pretty much it. Linda, let's open up the floor for questions. My final slide just gives an indication of the fact that we have a book available on our website, free for download. It's a PDF. They can just go in there and download that information that summarizes at a high level what kind of applications and connectivity is possible for IoT for business uses.
Great presentation, Zee. Again, I'd like to remind the audience, if you have any questions, please submit them in the Q&A box.
Okay, so let's dive into some of the questions. Linda, do you want to read them off, or I can read them off either way?
Yeah, sure. I'll read them off to you. So here's a question from the audience. Can you share your recommendations on really successful implementation whose case studies can be looked at?
Oh, absolutely. If you go, I'm going to answer the question with a go look on our website kind of response, and I apologize for that. But the fact is that we've done some case studies in a variety of different markets having to do with connected cars, with vehicles, with medical, and they are available on our website. In fact, there are some attachments that we've already provided for how you might want to make a decision on some of those. It's available right to you on that link that you can download, how to choose connectivity, trying to do the data analytics on the data. So you can download those. But if you look on our website, you will see a number of case studies which would be relevant for you. So I would recommend that you go take a look at that. And we're not unique in providing these case studies, frankly, to be honest. But if you go look at where we've been very, very successful, I think you will get a feeling for what's possible. IoT has a tremendous impact on all kinds of industries and markets, and you'd be amazed at what people are doing with it.
Thanks, Zee. My other question is, can you also comment on the emerging trends in the industry where these will become commonplace to use for consumers, like wearables?
That's a very good question. If you look at the data requirements for wearables, particularly when you are assuming that there's a human being involved, these technologies, the cellular LPWAN standards technologies, are not necessarily the obvious choice. If you look at the healthcare industry that is providing personal monitoring devices like Fitbits and the like, these tend to be Bluetooth, they tend to be low power Wi-Fi. Those technologies are more amenable to these customers because the folks who are using these kinds of devices also have smartphones. So the communication range is generally pretty straightforward. The data is usually being sent to a smartphone for the personal use of the individual gathering that data. It doesn't need to go further, meaning that they don't necessarily need to provide their Fitbit data into a cloud solution. Having said that, there are technologies that in the medical space where the data needs to be provided to a healthcare professional. So I think LTE-M is an exceptionally good transport for the kinds of medical devices that you can see in the near future. Today, for example, I think that the diabetic monitoring industry has been making products for transmitting via Bluetooth to your local smartphone. They haven't been making products for sending that data on to for healthcare scenarios which might require public health monitoring to be done. For example, I can think of some new products that measure the temperature of people or measure the volatile organic compounds, VOC, from people who are having particular medical issues that would need to be reported to a public health service. And those are the areas where I think some of the cellular LPWAN technologies may make a lot more sense for wearables or taking diagnostic data. Telehealth has one interesting flaw, which is that it's easy to take basic measurements like blood pressure and heart rate and temperature and provide that to the doctor. But how do you measure disease remotely? How do you measure that the person might have tuberculosis? How do you measure the person might be have a COVID-19 exposure. Those are the kinds of difficulties that we need to overcome with battery-powered devices in the future, and where I think LPWAN will play a role.
Great, thanks, Z. Another question is, are there checklists of questionnaires that can be used to make your assessment on LTE-M versus NB-IoT?
That's a good question. We try to not provide generic responses. Even though I gave you a basic set of questions and answers that you can ask yourself, it's never easy to drive a particular solution and say you have to use LTE-M or you have to use NB-IoT unless you get more details from the application. So the best way I would encourage people to do that is to call us, talk to us, and the other experts who are deploying LTE-M and NB-IoT, because we have experience, we know what's going on. We can help you make a decision one way or the other as to which may be a better choice. There's some obvious points. If you need voice, obviously you're going to use LTE-M. If you need mobility as part of your application, you're going to need LTE-M. If you need 10-year battery life, well, then you need NB-IoT. So there are decisions that need to be made. There are radio service module providers who are making devices that work on both networks. How you use it, in which mode you use it would be something to think about. Obviously, when you eventually get to NB-IoT radio modules, the pricing of those will be lower by significant percentages. So if you're deploying millions of devices, that may have an impact on your decision. No simple answer, but come talk to the experts who are helping you.
And one more question. Can you please share the applications of LTE-M versus NB-IoT? Where are these used?
Good question. Let's look at NB-IoT first, and I'll go to LTE-M. You can start seeing NB-IoT solutions in places where the need for real-time data is not paramount. So, for example, if you're doing a measurement of propane tanks, as the example that I used earlier, where you want to monitor the level of propane in a tank, because a service provider who comes by and does the refills for a propane tank refill doesn't need to know that it's precisely 40% full at this very instant. All they need to know is if it has dropped below a certain threshold, and they need to come out in time to make sure that the tank isn't emptied. That's an example where NB-IoT makes a lot more sense. In particular, they want to not have to touch the units often, so a battery-powered device makes a lot of sense. And as a result, NB-IoT might be more appropriate. Now, if you look at a medical PERS device, a personal emergency response device, where a person who has had a medical emergency or needs assistance needs to communicate, push a button, transmit the data, and then communicate with a support person, that's where you need a voice. Okay, so you can see Emperor's devices starting to use LTE-M. The fact that the device may not need to be powered for 10 years is good. If it lasts months or a year or two, then that's appropriate, because the human wearer of that Emperor's device can in fact recharge the unit with its rechargeable batteries potentially in time for making many more months of usage happen. I can see the medical community starting to use LTE-M much more heavily than NB-IoT. On the other hand, if you have a need for doing a data transmission from, let's say, a medical monitoring device for blood pressure, then NB-IoT would be quite sufficient.
Thanks. I think we have time for one last question. When will 5G be available for IoT applications in North America and globally?
When do you see 5G being available for applications? Wow, that's a good question. I'm going to have to predict the future a little bit. Let's look at it from the following perspective. If you look at 5G, and I mentioned this earlier, LTE-M and NB-IoT are available today. It's part of the 5G spec. It's available for use today. Now, if you want the ultra-high-speed performance capabilities of 5G, that's not going to happen until you get to what's called the centimeter or millimeter wave deployments of 5G at many multiple tens of gigahertz. That's not going to happen in major cities for a few, except in major cities, for a few more years. I do not see it happening on highways and secondary market and tertiary markets very rapidly. In fact, if ever, because the cost of deployment for 10 gigabits per second service out on the highway simply doesn't exist today. It could happen in time, years from now. So let's find that middle ground. Where do I think 5G will happen? Somewhere between 3 to 4 or 5 years maximum you'll start seeing 5G being pervasive enough in most major cities that you can deploy applications that take advantage of the high-speed performance if you don't need LTE-M or NB-IoT for those applications. So 2024 might be the right date for the radio costs to come down, for the service coverage to become totally available for the high-speed 5G deployments that are necessary in major cities, urban environments. Today, LTE-M and NB-IoT is available in many countries, not all countries. There are about well over 130, maybe 150 carriers that have deployed NB-IoT, but not in their entire footprint. It's going to take some time. And LTE-M is very similar in deployments to LTE. So if a carrier has LTE, for them to migrate and support LTE-M as well is not a big deal. They can get that done pretty quickly.
Great, thanks, V. I think that's all the time we have for questions. Any questions that we didn't answer during the webinar will be answered via email. Thank you, V, for an awesome presentation. Thank you to the audience for joining us today. We hope you learned about IoT connectivity and best practices for digital transformation. If you have any questions, feel free to reach out to us. Thank you and have a great day.
Thank you, Linda.